All right, in today's lesson, we're going to move on from talking about the general category of polygons to more specifically parallelograms. So please remember to go back and write in your essential question when we get finished. Our learning target says, I will use properties of parallelograms to solve problems involving angle measures and side lengths. Of course, we're going to start with the definition of a parallelogram, and it is a quadrilateral with both pairs of opposite sides parallel. That's what a parallelogram is. Parallelogram. And to be short, I will oftentimes write it like this. You know, that's the symbol for parallel lines. So I'll just put parallelogram. It's not a great thing to do, but I will do that a lot. And so you can do that when you're writing your proofs if you're so inclined. Okay, now we got a lot of theorems, so let's just fill them in. If a quadrilateral is a parallelogram, then as we can see from this drawing here, its opposite sides are congruent. Next, if a quadrilateral is a parallelogram, then its opposite angles are congruent. We can see that that's what the markings show. Third one, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And you better be making these flashcards if you haven't already, because you will have to remember all these theorems. Now, let me just say this. These theorems don't have a name. So let's say I were going to use this first one here in a proof. If that were one of my reasons, what I would do is I would say theorem colon opposite sides of a parallelogram are congruent. So you can abbreviate it like that in your proof. You don't have to write it as an if-then statement. And before I forget, I want to highlight one thing here. Whenever we're labeling parallelograms, let's say we want to call this parallelogram that I've drawn over here ABCD. If I start here with A, then I have to go clockwise. Oops, sorry, that should be D. Okay, ABCD. So in other words, if that's parallelogram ABCD, if they tell me, let's say they tell me parallelogram JKLM, I couldn't do this. I couldn't say JKLM. That would not be correct. Whichever vertex I start labeling with, I have to go counterclockwise. Or you could go, I meant to say clockwise. You could go counterclockwise too, but you do have to label them consecutively based on the letters that you are given. That's something that's important to remember. Okay, next theorem says, if a quadrilateral is a parallelogram, then its diagonals will bisect each other. That's a good one. Doesn't say the diagonals are congruent. It says that they bisect each other. And then we've got this final theorem here before we do some practice problems that says if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. I'm not going to spend too much time on this because frankly, I don't really remember a time in this unit that we're going to use that. I think they put this theorem right here because perhaps they needed to use it to prove another theorem, but we don't need it right now, so we're just going to leave that there like that. And we're going to start on our practice problems. Okay, so let's see what we got. STUV is a parallelogram. Find TU. So here's TU right over here. And WT. WT is right here. And it says justify your reasoning. Okay, well I know that TU is 12. And how do I know that? If this were a theorem, I would say my reason is theorem opposite sides of a parallelogram are congruent. That's what I would write if I were writing a reason. And then WT here is going to be 14, right? And again, the justification for that would be the theorem that says the diagonals of a parallelogram bisect each other. Okay, again, in a proof, you don't have to write your theorem as an if-then statement, but you got to say theorem, colon, and then abbreviate it in such a way that I know what you mean. Okay, here we have JKLM on problem number 2 is a parallelogram, and they have it marked. This is how I know it's a parallelogram. They're showing me that opposite sides are parallel. Is that a theorem or a definition? That's the definition of parallelogram. Don't forget. All right, the measure of angle M is 135. I want to know the measure of angle L. Okay, well, I got a theorem that says consecutive angles are supplementary. Therefore, the measure of angle L has to be 180 minus 135, and that would be 45 degrees. What about the measure of angle K? Oh, it's congruent to M, so it would be 135, and so forth. Okay, ABCD in number 3 here is a parallelogram. Find the value of X. Let's see what all we got left here. Find the value. I'm going to let you do numbers 3 and 4. I want you to pause here. I want you to use those theorems that we just learned. Do 3 and 4. Come back and check your work. Okay, let's check these two out. On number 3, I know that angle C is congruent to A, so their measures are equal. So I just set those two expressions that they gave me in there equal, and I solve for X, and I get X is 12. If you have any problem, put a star on it. Ask me about it in class tomorrow. Number 4, we got to find the measure of angle D, the value of Y, the value of X, and EH. Okay, it's marked, so we know it's a parallelogram. So I know that this angle right here that measures 50 degrees, and this angle over here that measures 7x plus 4, because of the theorem, I know that those consecutive angles are supplementary. So I did that in this step right here, and I ended up finding that X equals 18. All right, figuring out what Y is, well, I know the opposite sides of this parallelogram are congruent, therefore their measures are equal, so I set 6y minus 9 equal to 21, got y equals 5, and then they wanted me to find the measure of angle D. Well, I know that angle D is congruent to its opposite angle, so it's 50 degrees. And also I know the diagonals bisect each other, so because GH equals 8, I know that EH has to equal 8 as well. All right, let's see what we got now. Find the links to the diagonals. Okay, well, I got to go back to the proof that tells me the diagonals bisect each other. Therefore, what do I know here? Well, I know that X equals Y plus 2 because of diagonal LN. And then because of diagonal Km, I know that 2x minus 8 equals y plus 10. Okay, let me get these little stray marks off here. All right, so what do we got? A system of equations. This set of equations is going to be easy to solve by substitution because my first equation is already solved for x. So I'm going to take that value of x, going to plug it in right there. So I got 2 times y plus 2 because x equals y plus 2. Now I've got one equation, one unknown. I can solve it. 2y plus 4 minus 8 equals y plus 10. So subtract y from both sides. I get y equals 10. And let's see, that's going to be negative 4 on the left, so plus 4. So y equals 14. Y equals 14. So if I want to solve for x, I'm just going to go right up here and plug that 14 in, and I'll get x equals 14 plus 2, which is 16. Let me just see if that makes sense. It definitely makes sense for diagonal LN. How about diagonal KM? Let's see, 2 times 16, that's 32. I'm plugging 16 in right here. 32 minus 8 is 24. 14 plus 10 is 24. So, yep, I believe I have the correct answers here. Okay, now we're going to do a proof, and this is the last thing of the day. So let's set it up. I feel like we haven't done a proof for a while, so this is very exciting. Statements, reasons. Of course, we have to number them all. I know the first one is going to be given. I'm going to write down the given. And when I have this little symbol here, that means ABCD is a parallelogram. So I've got parallelogram ABCD, and they want me to prove that AB is congruent to CD and BC is congruent to DA. Okay, they're wanting me to prove the theorem that says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So we can't use that theorem because that's what we're proving. So let's see what we know here. I know that AB is parallel to CD, and I also know that the other set of opposite sides, BC, is parallel. I'm going to call it DA because that's what they called it up there. And how do I know that? Because that's the definition of parallelogram. Opposite sides are parallel. Okay, so how does that help me? Well, if this is my transversal, if I let this diagonal here, AC, be my transversal, then what do I know? I know that angle 1 is congruent to, let me use, yep, angle 1 is congruent to angle, well, hold on a second. If I'm looking at AB, yeah, I'm going to say angle 1 is congruent to angle 4 because of those two parallel lines. And then I also know that angle 2 is congruent to angle 3. And how do I know that? Oh, because they're alternate interior angles. So the alternate interior angles theorem. Been a while since we used that. I hope you didn't forget it. Okay, so I've got 1 congruent to 4. I've got 2 congruent to 3. Oh, so what I think I'm going to have to do is to show that triangle ABC is congruent to triangle CDA, and then ABCD and BCDA will be corresponding parts. So how can I get that these two triangles are congruent? Oh, how about if I say AC is congruent to itself? They both share that side, and that, of course, is the reflexive property of congruence. Put me a little squiggle mark on there like I like to do. So now I've got it. Triangle ABC is congruent to triangle CDA, and please remember to match up your corresponding angles. Order does matter. CDA, and that's angle side angle, right? I used angle side angle to do that. And so finally, now that I know that AB is congruent to CD, and I know that BC is congruent to DA because they're corresponding parts of congruent triangles, and therefore they're congruent. So that's that. Write yourself a little summary so you'll remember all these theorems and be able to know the difference between the theorems and the definition of parallelogram, and we'll see you next time.